the electronics device, electrical devices require the electricity, and electricity comes from the thermal power plant. So we must focus on the different type of the renewable energy sources. So there are nowadays most of the electricity. So but how we can increase the different renewable energy production? So this will be, what do we need the microbial? Why do we need the microbial fuel cell? Because most of the electricity generated from the wind, solar, different types of the renewable energy like the solar and solar energy, wind energy, hydro energy, and biogas energy. All these type of the renewable energy is used to for the industrial application and industrial applications, and different types of the remote area, powering the remote areas where the conventional electricity is not available. But all these type of the renewable energy sources not available for everywhere, because solar energy is required the sun energy, and wind energy required the wind, and hydroelectricity power, hydropower plant required the dense waters in, and different these are the different renewable energy sources. This is these all these type of the renewable energy is not suitable for the everywhere. So microbial fuel cell is available, can be implemented anywhere, any type of the environmental conditions. Only the requirement is the water environment. So this is the basics about the fuel cells. Fuel cells is a device that convert the chemical energy from the fuel into electricity through a chemical reactions with oxygen or another oxidizing agent. Similarly, the microbial fuel cells is a bioelectrochemical device that harnesses the natural metabolism of the microbes to produce the electrical power directly from the organic matter. So, what is the metabolism of the microbes? Let us take an example. Why we eat food? We eat food to produce the energy, gain the vitamin, protein, etc. This is our metabolism. And microbes exactly do the same. They eat organic material, then produce the energy for themselves. This is the metabolism of the microbes. But some of the microbes, bacteria, liberate the electron during this metabolic activity. So this is the basic principle about the microbial fuel cell. In, there are the two chambers, anode chamber and cathode chambers. In anode chamber, placed in the organic matter may be different types like the river sediment and paddy field sediment, wastewater treatment for plant waste materials, industrial waste we can use as a organic matter in the microbial fuel cell. So anode is placed in the organic matters, and organic matter, in the organic matter microbes is present which liberate the electron, protons, and carbon dioxide with the help of the oxidation reactions. And in the cathode chamber, with the help of reduction reactions, oxygen, proton, and electron combined and converted into the water. So electron produced in the anode chamber flow from the external wires through the anode to cathode and produce the electricity. This is the basics about the microbial fuel cells. So generally there are the two type of the microbial fuel cell. One where when the proton exchange membrane is used, called the double chamber microbial fuel cell. In the microbial fuel cell, when the proton exchange membrane is not used, called the single chamber microbial fuel cell. So when the proton exchange membrane is used, the overall cost of the microbial fuel cell is increased, and so the single chamber microbial fuel cell, the overall cost is reduced because the membrane is very costly, and different organic materials used in the MFC in the anodic chambers, which responsible to the generate the electricity. So various things like the glucose, acetate, lactate, phenol are used as a organic matter in the MFC, and different waste materials of the wastewater treatment plant is also used. Paddy field, seawater sediment, and river sediment, and industrial waste sediment is used as a organic matter is in the MFC, microbial fuel cell. All these organic matter is the freely available in the environment, and there are a lot of application of the microbial fuel cell for the electricity generations or wastewater treatment and biohydrogen productions, and it can also used to powering the electronics devices, sensor devices, and it also used for the BOD and COD removal from the wastewaters. And there are the lot of advantages of the microbial fuel cell. It's directly convert the substrate energy to the electricity, enable high conversion efficiency. It's has the longer life. It is pollution. It's generate the electricity without creating any pollutions, and it is maintenance free, and it requires only the water environment. And only the disadvantage of the microbial fuel cell, it's has high cost, high weight, large volume, and the major disadvantage of the MFC is their low power density as compared to the lithium ion battery. And the microbial fuel cell do not require the charging. It's continuous providing the powers, only the continuous providing the powers. And the challenge, there are the lot of challenges for the microbial fuel cell. It has the low voltage generations, and its design cost is too high, and it's suffering the voltage reversal problems. The voltage reversal problem is that when the microbial fuel cell connected to the load, the voltage of the microbial fuel cells directly reduces. And this is the practical applications. One of the another challenges is the practical application, how it make the comfortable to powering the electronics devices. So there are the how to so motivation behind it, my motivation behind it to filter out these challenges is is the solar cell. Because a single microbial fuel cell generate the 1 volt, and a solar cell is also produce the a single solar cell also produces the 0.5 volts. So this is the development of the microbial fuel cell for the electricity generations. And first time 1719, Lungi Galvani is observed examining the bioelectricity and bioelectric phenomena. And the first time this microbial fuel cell is used to powering the some electronic device in the flight. In the flight, NASA is used in 1950, and so on. This is the history about the microbial fuel cells. And this is the different configuration of the microbial fuel cell. There are the lot of configurations has been designed by the researcher to increase the power generation, to increase the power density, to increase the voltage, and a lot of different type of the anode and cathode material has been also used to increase the voltage and power, increase the power density. So there are the different cathode material, anode materials like graphite. In the anode and cathode material, graphite felt carbon papers are used as a electrode and cathode material, and different proton exchange membrane is also used, like Nafian membrane, salt rich types. Proton exchange membrane has been used in the MFC. Or this is the objective for the practical application for the microbial fuel cell. Because the microbial fuel cell generate the very less low voltage, it is not useful for the powering the electronics device. So in my research, my focus to implement the power management system and comfort the microbial fuel cell to make the comfort the microbial fuel cell to powering the electronics devices. Most of the electronic devices require the 3 volt, 5 volt, 9 volt, 12 volt, as well as 230 volts power supply. So my research is focused on the implementation of the power management system for the powering the electronics devices. This is the first implementation basics about the implementation of the microbial fuel cell. I have implemented the sediment microbial fuel cell by collecting the Ganga river water sediment, and different electrode materials has been used, like the zinc and copper electrode materials, zinc and graphite electrode materials in the microbial fuel cells. And this is the measurements of the voltage, current, powers, methods of the different microbial fuel cells. And this is the voltage generation of the different microbial fuel cells. A maximum voltage is observed 1.16 using the copper anode and zinc cathodes. And this is the power density polarization curve of the sediment microbial fuel cells. And the single sediment microbial fuel cell produce the current of the 1051 microamperes, and voltage is the 1.16 volt. This is the very low voltage of the sediment microbial fuel cell. But a single sediment microbial fuel cell as compared to the solar cell, a single solar cell also generate a voltage very low voltage like 0.5 volt. So as compared to the solar cell and microbial fuel cell generate the maximum voltage as compared to the solar source. So based so further, I have implemented the different type of the microbial fuel cell connected in the series and parallel combination in order to increase the voltage and current. So by connecting the 8 SMFC microbial sediment microbial fuel cell, we observed the 8.15 volt. So it can be used to powering the LED light. A single LED light is required the 3 volt level. So it is implemented. 8 SMC are connected in the series and parallel combinations to powering the small LED light as shown in the figures. Figure 3. A small LED is glow through the 8 SMFC by connecting the series and parallel combinations. So this is the different this is the parameters or different chemical parameters available in the organic matters, which is responsible to produce the voltage like zinc, organic carbons, and boron, magnesium, sulfur, iron, phosphorus, electrical conductivity. All these chemical parameters is also responsible to produce the voltage in the microbial fuel cells. And further, I have implemented a power management system for the 3 volt power supply, because most of the electronics devices require the 3 volt power supply. And like sensor devices and LED lightings and wireless sensors are required the 3 volt power supply. So these microbial fuel cell, a single sediment microbial fuel cell generate the 1 volt. So we have implemented a power management system to increase the voltage of the microbial fuel cell to provide the power to the sensor device like at the 3 voltage power supply. So a single sediment microbial fuel cell generate the voltage and provide the voltage to the power management system for the 30 second. So a, in this power management system, a boost converter has been used. This boost converter increase the voltage of the microbial fuel cell up to the 3 volt. So a single sediment microbial fuel cell connected to this power management system, it provides the power to the 30 for the 30 second. So I have implemented 4 microbial fuel cell connected in the parallel one by one to the power management system for the continuous power supply. So these ideas, this research work has been published in the ASCI Journal Energy Research. And further, I have implemented a power management system for the mobile charging and 3 watt LED lighting. So I have implemented the different microbial fuel cell like 24 sediment microbial fuel cell has been implemented and connected in the series and parallel combination. And a power management system has been used in this to increase the voltage up to the 5 volt for powering the for the charging the cell phone battery. And this power management system consists a boost converter. Boost converter is used to convert the DC to DC voltage, increase the DC voltage. So this boost converter is a special type. It's work on the very low voltage. And this boost converter increase the voltage and regulate the voltage up to the 5 volts. And this research has been published in a biosensor and bioelectronics journal, SCI journals of the Science Direct, elsewhere journals. And further, I have implemented a a power management system to increase the voltage for the 9 volt and 12 volt power supply, because most of the electronics devices require the 9 volt and 12 volt power supply. So uh, this power management system is able to increase the 9 volt and 12 volt power supply. And what is the importance of the power management system? Because we cannot directly connect it to the sediment microbial fuel cell to the load, because sediment microbial fuel cell suffering the voltage reversal problems. That's why a power management system has been implemented to increase and control the voltage for powering the loads. So this boost converter is the based on the XL6009 IC based. This boost converter is a single boost converter is able to increase the voltage or the 9 volt and 12 volt power supply. So this work has been published in this paper in a international journal of the hydrogen energy, elsewhere journal, SCI journals. And further, I have implemented a inverters to convert the to convert the DC voltage into the AC. First, I have charged the 12 volt charged the 12 volt battery by these power management systems using the stock SMFC. I have implemented a stock MFC by connecting the 72 SMFC in the series and parallel combinations. After that, these stock SMFC can be used to power the powering the boost converter. This boost converter is based on the XL6009 IC based. This boost converter is able to increase the increase the stock SMFC voltage up to the 12 volt. So it is this a 12 volt battery is charged by these power management systems in the 9 days. And after charging this battery, it's a inverter, a multi-level IC based inverter has been implemented to convert the DC voltage into the AC for the 7 watt LED lighting. So this is the waveform for the DC input and output of the inverter. This is the DC voltage 12 volt, and this is the AC voltage of 230 volt AC power supply. And this LED lighting is glowing for the 6 hours after charging this 12 volt battery. And this is the laboratory setups in which the LED lighting is glowing through this inverter. A inverter is used, and this is the power management system in which a boost converter is used. And this is the sediment microbial fuel cell. Different sediment microbial fuel cell is connected in the series and parallel combinations. And this is the inverter photographs. And this research has been published in the Journal of the Power Source. This is the elsewhere journals, SCI journals. For more detail, you can follow these papers. And this what is the future scope of the microbial fuel cell? Because most of the remote area is not in this time is also not available the conventional electricity, and conventional electricity is not available to the remote area. So these type of renewable energy can also provide the power source for the electronics device like the LED lighting, mobile chargings, and seawater remote navigations. Because in the remote area, sea there is not available the conventional electricity, and there is this microbial, this type of renewable energy is also used for the remote area and sea waters, remote sea in the remote sea for the powering the wireless sensor devices. And military application is there are also applicable for the military application, because for the mobile charging and wireless powering the wireless sensors and walkie talkie etc. And it is also applicable for the cyclones area, because the more than 1 month is conventional electricity is lost due to the thunderstorms and cyclones. So this power source is also applicable in the cyclones areas. And this is the different a lot of the future scope of the microbial fuel cell. For there are the different implementation of the microbial fuel cell on the reduce